The Chernobyl nuclear power plant collapsed in an instant. Why did the meltdown that shook the world truly happen? A 30 kilometers radius became an exclusion zone, over 200,000 people evacuated. Enormous recovery costs and radioactive contamination persist to this day. But beneath this unprecedented catastrophe lay structural problems of human and organizational nature, issues that continue to repeat in modern society. What was their true essence? In this documentary, we unravel why dangers were ignored, who concealed what, and what lessons emerge for organizations today. Now, let's delve into the full scope of the Chernobyl disaster, humanity's greatest mistake. The main feature also provides a detailed explanation of the dark side of the Soviet regime. In the 1970s, the Soviet Union positioned nuclear power as a symbol of national prosperity, constructing the world's largest RBMK reactors. The Chernobyl plant, located approximately 800 kilometers from Moscow, boasted state-of-the-art technology. All 4 units, once operational, were expected to supply immense power. The RBMK reactor served a dual purpose: economic electricity generation and the production of plutonium necessary for nuclear weapon development. Soviet scientists believed this design was cutting-edge, leading the world. Their confidence, however, sometimes turned into arrogance. They over-relied on their own technological prowess and political system, tending to disregard potential dangers and foreign safety standards. Chernobyl was the core of the Soviet energy strategy, a beacon of hope supporting rapid industrialization and development. In the surrounding area, the planned city of Pripyat was built for nuclear plant workers and their families, promising a prosperous life. Everything seemed to be going smoothly. The Soviet Union firmly believed it had absolute control over the immense power of atomic energy. However, the RBMK reactor had a fatal design flaw, a structure known as the positive void coefficient. This was a dangerous characteristic where the reaction accelerated if cooling water evaporated, a feature not found in reactors in other countries. Furthermore, the tips of the control rods inserted during an emergency shutdown also had a structural flaw that temporarily accelerated the reaction. These flaws were strictly concealed by the Soviet government and the nuclear industry, and were unknown to the operational staff. Accidents and near misses had occurred with RBMK reactors in the past, but all were classified as state secrets and never shared. In an environment of closed information, awareness of danger did not develop, and improvements in safety measures stalled. On the contrary, to promote Soviet national prestige, the plant's safety was continuously advertised to the international community. Everyone believed their technology was perfect. The very idea of a flaw was considered an act of treason against the state. On the day of the accident, April 26, 1986, Reactor Unit 4 at Chernobyl was about to undergo a test of its emergency diesel generators. This was a dangerous test, intended to determine how much electricity the turbines could generate by inertia during a power loss. The test plan was riddled with deficiencies and included operations that could render the reactor highly unstable. Furthermore, inexperienced night shift operators were instructed to proceed with the test, without fully understanding the risks involved. They ignored established safety procedures, sequentially compounding multiple operational errors. The reactor core dropped below its minimum design power, nearing an uncontrollable state. But at this point, a hidden pitfall unseen by anyone opened up: the concealed design flaw of the RBMK reactor. The Soviet planned economy consistently prioritized quota fulfillment, fostering a culture that valued productivity over safety. Pressure from superiors, coupled with the Concorde effect of being unable to stop a test once begun, dulled the judgment of those on site. Information distortion also exacerbated the situation. Without knowing the truth about the reactor's dangers, operators couldn't foresee the worst-case scenario. Organizational groupthink stifled dissent. Questioning a superior's orders was, in itself, not allowed. Prestige over safety, the state over the individual. Such a system transformed small mistakes into fatal failures. Furthermore, the reactor's designers themselves refused to acknowledge its flaws, blurring the lines of responsibility, which was also a problem. Even as the crisis loomed, they clung to the belief that our reactor is safe, continuously underestimating the situation. Not a single person stopped this experiment, and the fated hour drew ever closer. At 1:23 a.m. and 40 seconds, to halt the reactor's runaway, an operator pressed the emergency shutdown button, AZ5. However, the control rod flaw backfired. The reaction temporarily accelerated, and the reactor core's power surged to 100 times its design capacity. The fuel rods within the reactor were destroyed, and the cooling water instantly vaporized. A steam explosion occurred, blowing off the 1,000-ton upper structure of the core. Immediately after, a chain of hydrogen explosions followed, completely destroying the reactor building. Flames and radioactive material soared into the night sky. Firefighters engaged in a desperate battle to extinguish the blaze, but they were unaware of the invisible threat of radiation. The core melted and widespread, severe radioactive contamination began. It was the moment of history's worst nuclear disaster. The Chernobyl disaster showed the world how dangerous information concealment can be. A lack of transparency leads to irreparable consequences. It also became clear that when organizational hierarchy is absolute and on-site voices are disregarded, risks escalate. Why were dangers ignored? Because Soviet secrecy and the structural flaws of the RBMK reactor were concealed, and information never reached the operational staff. Who concealed what? Designers and the state hid information, leaving on-site personnel unaware of the risks and unable to defy orders. What are the lessons for modern organizations? The fact that even the most advanced technology, coupled with a lack of transparency and arrogance, can lead to irreparable consequences. No human-made system is perfect. A humble approach and continuous efforts for improvement are always required. The tragedy of Chernobyl continuously poses a question to us. What will you learn from its failure? There's a difference in decision-making quality between those who know this failure and those who don't. History is always a guidepost for the future.